All right, and we are back with some more notes. So we are into the last section. However, I'm going to be splitting this up into two parts again. Trying not to overwhelm you with just one set of videos. So we are into solving equations. Solving equations are the last little bit that we are going to get into. So let's do this. When you are going into solving equations like this, normally if you're solving for an x like this, you're going to kind of do the reverse of BEDMAS. It's typically kind of what you're going to do. There are going to be a little bit of exceptions on this, so I'm not hugely stressing reverse BEDMAS or SAMDES or whatever some people call it nowadays. But basically, we're going to work intuitively through stuff like this. So let's dive into this. We've got 2x minus 5 equals 35. So if I want to get x by itself, I need to get rid of all this outer stuff first. So 2 is being applied to the x first, so I'm going to get rid of that last. So what I need to do first is get rid of this 5. I'm going to show you explicitly what the steps are at first, and then a little bit later I'm going to not show you these explicit steps because it starts to get quite tedious trying to do this. So what do you want to do? You want to add 5 onto both sides here to get rid of this. So to get 2x equals 40. And then to get x by itself, divide by 2, divide by 2, 20. So pretty basic, trying to do something like that. Here's your final answer. Let's try another one here. Let's try C, because that one you should be able to do. So there's a few ways you want to do this, but I'm just going to get rid of 15 on both sides first. Get rid of this, so I get x over 5 equals 10. I've got x divided by 5, so I'm going to multiply both sides by 5. That cancels this, and I get x equals 50. You want to double check, you can plug it back in, make sure it works, but it should work. Something with brackets like this, do the bracket first. It's always great to start with that. You could, I guess in theory, you could just divide by 2 first. That would be pretty straightforward. That's another method you could do. I didn't think about that. So you get this. So I just expanded. Subtract 14 from both sides. This cancels. You get 2x equals 70. Divide by 2, x equals 35. Like I said, if you wanted to do a different method with this, what you could do, if you wanted to, you could just divide by 2 first. So you've got 2x plus 7 equals 84. You could divide both sides by 2 to get rid of this. You get x plus 7 equals 42. Subtract 7, x equals 35. That way is quicker. That works too. I didn't think about it. Both methods work in that case. So that's solving something pretty straightforward. Let's get into a little bit more complicated. It's not a lot more complicated, just a bit. Something like this. So notice here we've got x's on both sides, so it's slightly problematic. What you want to do is get those x's on the same side. And that doesn't just mean, oh, subtract 3x onto here, done. No. You need to first simplify each side first as much as you can, and then gather the x's. So there's some steps here that you can get into if you want to. It just helps to go through it. So getting rid of brackets first. Brackets are pesky. Denominators, try and get rid of any denominators you have. Those are also pesky. Collect like terms, bring the variables together, and then work on what we did up above. That's a strategy you can use. You won't have that listing on the test, but that's kind of the guidelines to follow through it. So as you're starting off with the questions, work with these. And if you want to memorize it, you can, but eventually it just starts getting to be routine. So brackets first. Here I'm going to stop showing the explicit steps. So you'll just have to follow along with what I'm doing here. I did the brackets. Next thing, denominators. We have none, alhamdulillah, so we're good. We don't need to deal with that. Let's deal with like terms on both sides. 2x minus 15 equals 15x minus 18. So I just combine those two. Then I am going to get the variables together. So they say here, move the variables to the left, move the numbers to the right. You can do it that way. If you want to just bring the smaller one over, that's fine as well. Like what I would do here is minus 2x from both sides. So I'd end up with 13x minus 18 here. Then I don't have a negative with 13, but again, that's just me. Add 18 onto both sides, we get 3 equals 13x. Divide by 13, you get x equals 3 over 13. Like so. So that would be my strategy in going about this. Let's try another one. So these two, we've got fractions. So this is going to be helpful. So get rid of brackets, there are none. Great. Get rid of denominators. So in order to get rid of the denominators, I need to multiply every single term to get rid of these two denominators. So if I multiplied everything by 3, I would get rid of this denominator, but not this one. So I need to find something to multiply by that would get rid of all denominators. So in this case, I've got a 3 and a 2. So I'm going to take this entire expression, all of it, and multiply by 6. So each term that's in here, I'm going to multiply by 6. So 6 times 2x gives me 12x. 6 times 8 gives me positive 48. Now here I've got a divider of 3. So 6 divided by 3 gives me 2. So I'm just going to multiply this top by 2. So 6 divided by 3 gives me 2, times 4 gives me 8. So there's where that comes in. Equals 6 times 3 gives me 18x. And again, 6 divided by 2 is 3, times 5 gives me 15. So now I've gotten rid of all of my denominators. It looks like something over here. So I can collect all the like terms on each side. So over here, you notice I've got 12x minus 8x. So this gives me 4x plus 48 equals 18x plus 15. Bring the variables to the same side again. I'll do it the other way. I'll show what they say. So subtract 18x onto this side. So I'll get minus 14x equals, because I'm going to subtract 48 onto this side, which gives me negative 33, I believe. And then divide by negative 14, so I get x equals 33, negative 33 divided by negative 14. But because they're both negative, I can turn them into positives. And here's my answer. So that's what you're going to do. If you're trying to get rid of the denominators, you multiply absolutely everything by 6 to get rid of those denominators. So that's what you would do there. Let's do one more section here, quadratics. And then, what's after that? Then I'll stop there. And I'll cover the rest of this in the next class. So getting into here, so now we've got x squareds, or we've got x cubes, or even x to the power of 4s. So we need to know how to solve this. It's going to be very similar. You're just going to deal with that squared or the cube at the very end. So here, 4x squared equals 36. Well, let's divide everything by 4. So we get x squared equals 9. And then take the square root of both sides. So x equals the square root of 9, which is 3. However, I don't know if you've been taught this. When you take the square root, you need the positive and negative of that. Anyone else hear that music outside? Just me? Okay. So positive and negative. And that's because if I square a positive 3, I get positive 9. If I square a negative 3, I also get a positive 9. So when you take the square root, you need the plus or minus. They don't always teach this at younger levels, but this is very important, and this is going to occur a lot this, maybe not a lot this year, but next year it's going to be vital as well. So you need to remember this point. Let's try this one with the fraction. So I always told you get rid of the fractions first. In a simple expression like this, you don't have to, just because we do this x squared divided by 5, subtract 12 from both sides, we get 45 as such. And then you need to multiply both sides by 5. So x squared equals, I don't know what 45 times 5 is, and I don't feel like spending the brain power to do it. So this equals 225. So then take the square root, and x is plus or minus, again, don't forget plus or minus, 15. Plus or minus is important. Okay, so that is that for this last one. If you don't have it, this should be a 4, because that's missing. So that is this lesson, and I will see you in class with your questions, and then you'll be able to practice this.